Hello, it's Scott Manley here. Out at Mars, the Mars Reconnaissance Orbiter continues to probe the surface, and it actually sees changes over time, sometimes in very real time. On the left there, that is a landslide in progress, which was recorded by the high-rise camera. That is the color camera that records at very high resolution. Now, to give you an idea of where this is, I've switched over to Space Engine. This, of course, has a terrain map and a texture map for Mars. This is at the North Pole, and the North Pole, it's just coming into the summer. Now, the poles on Mars are actually quite active in terms of weather because, of course, you have the gases there, they evaporate during the summer, and then they move to the South Pole, and this action causes terrain, it causes weathering, and we have these cliff faces which are 500 meters tall here. At this point, we're obviously seeing the limitations of the terrain that we have in Space Engine, but I just want to get you down close to these things to get you an idea that these are not small, shallow slopes. These are actually quite steep, and they rise up high above the surface of Mars, and they expose layers of frost underneath. And of course, as this evaporates, this cliff will collapse, stuff will fall off the cliff. This is the black and white image for kind of general context here. From top to bottom, I believe that's about 5 kilometers, although this varies slightly because the altitude of the orbiter changes over time. To get the colour image, it's a narrower section in the middle, which is only about 1 kilometre wide, and of course that requires 3 different colours to be taken. This is a scanning type image, a push broom imager, as they say. As the spacecraft travels across the surface, it scans one line after the other, and the colours get laid up essentially one after the other as well. So this is what the centre section looks like, much more zoomed in. You can really appreciate the level of detail that they're able to get here. And it is pretty cool to actually catch a glimpse of this active event, and it's not the only one. There's several kind of active plumes along that cliff face here. And MRO has actually captured quite a few of these over the years. It was launched back in 2005 and entered orbit in 2006. And in 2008, I think this was the first image of an active avalanche that was recorded. This is in February 2008. More or less in the same part of the world. You see the latitude is about 84 degrees north, 120 degrees west. But for all the activity, these are static images, and despite my efforts to, Ken Burns everything up by panning and zooming across, it's just a static image, isn't it? Except that it isn't, because the way this spacecraft takes the images is it takes 3 colours at 3 different times. And so if you take these 3 different colours taken at 3 different times, turn them to grayscale and then display them in the order they were taken, lo and behold, you get an animated avalanche on Mars. It is really quite beautiful. This is Doug Ellison, by the way, who he didn't train as an astronomer. He trained to do multimedia design and then ended up at JPL because he was an amateur who loved to take the images that NASA shares and interpret them and work with them on his own. So he took measurements, he figured the whole thing moves about 9 pixels in maybe 1/10 of a second, and that corresponds to 21 meters per second. It's actually moving quite quickly. These clouds of dust are 100 meters wide and moving as fast as a car. You're not going to outrun these things, but don't worry, you're not going to be breathing this stuff in because it's Mars, and you should probably have your spacesuit on. He also applied the same analysis to the other plume and got roughly the same speed. And the great thing about this data was taken back in March. The image has been sitting on the server available for a long time. He's just the first person to decide to go out and do this. You don't need any special scientific training or anything to get access to this data. You just need to spend the time to download it and understand what it represents and what it's delivering to you. Of course, one of the reasons he had time to do this sort of thing is that the mission he works on is Mars Curiosity, and Mars has been in conjunction with the Sun, therefore it hasn't been downloading any new data. Although we just got some pictures back the last 10 days of images trying to look for any changes in the terrain to see if anything blew around. Nothing. It was just boring, really. But that's okay because the archives are extensive and there's many examples of things like dust devils blowing stuff around, the wind formations. And I think the fastest moving object caught on camera was the descent system of Curiosity itself. That's it under the parachute as it landed on Mars. Similarly, the Phoenix lander was caught during its descent. But at longer timescales, we have the parachute from InSight blowing around in the wind over, weeks after the landing. We have the tracks that were left behind by Opportunity. And of course, over longer timescales, over years, we see new craters being formed, new holes appearing, fresh marks on the landscape. And not only that, after they're formed, they change over time. Fresh craters frequently have ice in them, and the ice disappears as it evaporates. This is a sequence of images that covers about 4 months in total, and by the end, the water ice has almost completely evaporated. I could go on detailing every single possible change, but we did start this with a landslide, so let's end with a landslide. This is a small crater. It was only about 5 meters across, but it dislodged a darker dust from down below, and it was on a steep enough slope that this dust rolled down the hill like a very fine stream, essentially coating the surface of Mars in this darker material. And when the contrast, it's really, really obvious. It then hits this crater downhill, you'll see as well, and diverts around it. But yeah, this isn't water that's flowing, this is just dust that is flowing like a river. Now, of course, it would be fantastic to catch this one in action, but asteroid impacts are basically completely stochastic and random, whereas this happens continuously, more or less, as the temperature warms up on Mars. So that's why we get to see these movies, why we get to see this information. This is a really cool image sequence. And again, I want to stress that all this data is out there for anybody to use if you want to go hunting for cool things on Mars. I'm Scott Manley. Fly safe.